So modeling situations with differential equations. Kind of pull out a few things here. It says this unit contains one of the most important applications of calculus, which is obviously differential equations. This is guaranteed to be one of our 6 questions on our free response. A differential equation is an equation that involves an x, y, and a derivative of y. So we've talked about that. That's not new. A solution to a differential equation is a function that satisfies the differential equation when the function and its derivatives are substituted into the equation. And we did solve those earlier. We're going to solve them again with more particular solutions now that we have a little bit more calculus under our belt. So again, different ways you'll see a differential equation. Obviously, any equation that has a derivative. This has a first derivative and a second derivative. This has a first derivative and a second derivative, first derivative and second. It doesn't have to have both, but there has to be a derivative in the equation. Okay, so now this is going to go back to probably your Algebra 1 days, these 2 rules that you have to memorize. Direct variation occurs when a situation gives rise to a linear function. So I want you to highlight y equals kx. That is the first formula you're going to have to remember. And underline here, k is the variation constant, or you can call it the constant of proportionality. Either way, it's the constant. And what we typically say is y varies directly as x. So that's the key. Y varies directly at x. The moment you see that, you are writing y equals, y varies, k is my constant of proportionality, directly is times. It makes a linear function. Y equals kx. Okay. The second form would be inverse variation. And this situation occurs when you have something like y equals k over x. K is still the constant of proportionality. And this time we would say y varies inversely as x. Y varies inversely as x. So that formula, again, when you hear inverse, is y equals k over x. So pretty straightforward. If it's direct, it's linear, k times x. If it's inversely, it's k over x. Okay? So you'll typically see a multiple choice question that looks similar to these. I think I did pull these from old exam questions. But you just read it and then pick the situation that models it. So example 1, a particle moves along a straight line. Its velocity v, so here's where they're describing, is in math means equals, inversely proportional. So that's telling us the formula we're going with. And here's what it's inversely proportional to, the square of the distance s. Okay, so I try to write it out on my own first before I look at a choice. Velocity is, so v equals, inversely proportional is k divided by, and here's what it's proportional to, the square of the distance s. So that's s squared. So if I look at my choices, that looks like choice B. Okay, notice they didn't talk about the rate of the derivative, they just said the function velocity. Go ahead and read example 2 and try to write your own equation. James, what do you have for us?
W equals k over t.
I would say you're pretty darn close. I disagree with one of them. Which of those variables is wrong? Sage, what are you thinking? W. What should it be instead of just W? Why? You're 100% right.
But it says at a rate.
Yes. That's exactly it. So they're not saying the weight is inversely proportional, it's the weight at a rate. So this should actually be dw dt. Great job, though. Just nice catch on the rate there, too. dw dt equals k over t. Inversely is k divided by, and then whatever it says, too. All right, I don't know, a little more advanced. Try number 3. right, did we go with S or dsdt? Sully, what are you thinking? dsdt is perfect, and hopefully you found that four-letter word, rate. The learning rate for a skill S. So they are describing dsdt. Is, again in math, is equal. There's my equal. Proportional, so not inversely, just regular proportional, so k times. And here's what it's proportional to. The difference, what operation are we thinking for difference? Subtraction. The difference between the maximum potential for learning that skill, M, and the amount of the skill that's already learned. So the difference between M and L. Okay. So the rate of the skill would be describing dsdt. Is equal, proportional is my k, and this is what it's proportional to. Just slowly read the question. Let's go one more. Try, it's multiple choice there. Try example 4. All right, so we have an IV drip administers medication to the patient's bloodstream at a rate of 3 cubic centimeters per hour. At the same time, so two things are happening at the same time. Okay, we have the IV going in. The patient's organs remove the medication. So when you hear remove, what operation are you thinking? Subtract. So I think it should be something minus something, right? It's removing the medication at a rate proportional. So that's a K times the current volume. So I'm looking for a K times V, I think is fairly obvious. Rate proportional to the volume. So I think that eliminates this choice and this choice. Now, we just said remove means to subtract. So if it's coming in at a rate of 3 centimeters per hour and it's being removed at this, I would go with choice A there. Okay. Again, remove means to subtract it from the bloodstream or subtract it out. So I just have two little kind of mini topics here. So one question you're going to see is, modeling this differential equation. The second, if you flip the page, is verifying a solution to a differential equation. And again, you'll see this in the multiple choice quite frequently. So they'll give you some sort of equation, differential equation. So in this case, they gave us f double prime of x minus f of x. And they want to know whether these are solutions to the equation. So basically, if I substitute this f of x in all of its information, do I get 0 as an answer? Well, this equation needs f of x and f double prime of x. So I'm going to have to go find those first. So let's go get f prime. The derivative of sine should be cosine. And then I need f double prime. The derivative of cosine is negative sine. And now it says, is this a solution? Well, is f double prime minus f of x equal to 0? So if I take my f double prime, and I subtract my f of x, which was just sine, does that equal 0? Hopefully your answer is no. So I would say this is not a solution. So typically these are going to be multiple choice, and they're going to say which one satisfies the differential equation. So we'll pretend that was choice A. And all you have to do is kind of go through the choices. So you can't really work backwards. You just got to go through the choices. So let's see if B is the correct choice. 4e to the x. So I need f of x and f double prime. So first find f prime, then find f double prime. and see if you have a solution to that equation. Tom, what'd you get for f prime? Perfect. And keep going then, what would f double prime be? You got it. All right, so again, obviously you take your derivatives, you plug them in the equation. So I have 4e to the negative x minus, my f of x is 4e to the negative x. And in this case, that does equal 0, so I would say this is a solution. They're going to use a lot of c's on you, and that's okay, because remember, c is just a constant, so same idea. If I take the derivative of ce to the x, and c is a constant, and pretend it was 2e to the x, the derivative of 2e to the x is still 2e to the x. So the first derivative is ce to the x. And if I derive ce to the x again, I still get ce to the x. So of course, f double prime ce to the x minus ce to the x is 0, and this one too is a solution. Okay, so again, just a common, these two are just common multiple choice type questions that you'll see in either the calculator or non-calculator section. You obviously don't need a calculator to handle these. Example 2, determine whether the function is a solution of the differential equation. So I know y, and I have dy dx equals 4y. All right, so I want to find dy dx. I want to find this guy's derivative. So dy dx is equal to, the derivative of 4x is just 4. And now I can substitute that into this differential equation. So I'm going to say 4 equals 4y over x. And I actually know y is 4x. I'm going to make that substitution. So 4 equals 4 times 4x over x. So I substituted this into the dy dx. And then I substituted this into the y. So I've got 4 equals 16x over x, which gets me 4 equals 16. So I would say this is not a solution. All right, try B, same idea. Find dy dx based off your given y. Plug it in and see if you have a solution. Dan, what's your derivative of x to the 4th?
4x to the 3rd.
Perfect. 4x to the 3rd, so we'll substitute that in. So we have 4x to the 3rd equals 4y over x. And we know y is x to the 4th. So 4x to the 3rd equals 4x to the 4th over x, which does turn out to be 4x to the 3rd when we subtract those exponents. So I would say this one is a solution. All right, one more type that you'll see here is they'll ask you to solve for k. For what value of k, if any, and so sometimes they'll have there is no solution, is this a solution to this differential equation? Okay, so again, I've got to plug stuff into this differential equation. It needs a y and a y double prime. So I know y, I have to go get y double prime. So take a minute, talk yourself through that derivative. Just our E rule. Christian, what'd you get for the first derivative?
2e to the 2x minus b k e to the -3x.
That's beautiful. Again, k is a constant. It just stays in front of the derivative as you go. That's perfect. So y double prime. So it would be e to the 2x times 2. So that'd be 4e to the 2x minus 3k is the constant that stays in front. E to the negative 3x times negative 3. So plus 9k e to the negative 3. That's supposed to be an x, right? Did I write that wrong? That's my x, sorry. X. Okay. Again, these are just coefficients. They stay for the ride. There's not a variable here. K is a constant. You're finding k. So the constant just stays times the derivative of that value. All right, so now you want to substitute everyone in, and you have to solve for k. So we need 4 times y, and this is our y equation, e to the 2x plus k e to the negative 3x minus y double prime, which is what we had to find, 4e to the 2x, I'm going to use parentheses of course, plus 9k e to the negative 3x, and I'm setting that equal to 10e to the negative 3x. So once I find all the pieces I need, I'm substituting them in and cleaning up. So I'm going to do 2 things here. I'm going to distribute this 4, and then I also have to distribute the negative through because we're subtracting that quantity. So 4e to the 2x is 4k e to the negative 3x minus 4e to the 2x minus 9k e to the negative 3x is 10e to the negative 3x. Now, typically something nice happens, and I think it is happening here. I think my 4e to the 2x's are canceling. Those are opposite signs. And then I have like terms, of course. 4 minus 9 should get me a negative 5k e to the negative 3x equals 10e to the negative 3x. My goal is to solve for k, so I'm just going to divide that junk over. So I'm going to divide over negative 5e to the negative 3x, negative 5e to the negative 3x. I've got k. 10 divided by negative 5 gets me negative 2, and this divided by itself, of course, just reduced to a 1. So I think I just get k equals negative 2. Okay, but again, a pretty common type question that you'll see in the multiple choice. Doesn't matter what section they put it in, you don't really need a calculator for it. But finding that value of k. So we've got a few minutes here. Let's try the next page. Compare, slide next to your neighbor, talk to your new friend here. Compare with your neighbor as you go, but go ahead and let's try the couple examples that are there.